Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 38, in which I will discuss on continuous probability distributions. Now, I will try to give the concept of continuous probability distribution. When a random variable or variate capital X takes every value in an interval, it gives rise to continuous distribution of X. This is the real line, minus infinitive, here infinitive, plus infinitive, and a b an interval. If this random variable X takes every value in this interval, it gives rise to continuous distribution of a random variable capital X. For example, the distribution defined by variate means random variable, like heights or weights, are continuous distributions. In discrete probability distribution, we know that the random variable capital X equal to small x means X is a particular value. But in continuous probability distribution, the random variable capital X equal to small x means small x lies in a small interval. Therefore, the probability distribution of a continuous variate means random variable X, is defined by a function fx, such that the probability of variate X falling in the small interval be between x minus half dx to x plus half dx is fx multiply dx. Here the length of the interval is dx. Then fx is called, this fx is called probability density function, and continuous curve y equal to fx is called probability curve. The range of the variable may be finite or infinite. When range is finite, then it is considered as infinite by supposing the density function to be 0 outside the given range. Here, let value of fx in this interval, then value of fx outside the interval, that is in the interval minus infinity to a, in this interval minus infinity to a, the value of fx will be 0. Also, value of fx in the interval b to infinity will also be 0. Thus, if a fx equal to phi x be a density function denoted for variate x in the interval ab, then we write fx equal to 0 when x less than a, fx equal to phi x when x lies between a and b, and fx equal to 0 for x greater than b. The density function fx is always non-negative, and integration of density function fx, integration fx dx limit minus infinity to infinity is equal to 1. That is, the area under probability curve and x-axis is always unity. Now I will give the concept of distribution function. If small fx be a density function of a random variable capital X equal to small x, and if capital Fx equal to probability for the value of random variable capital X less than equal to small x and equal to integration fx dx limit minus infinity to x, then capital Fx is defined as cumulative distribution function or simply distribution function of continuous variate capital X. Now we will discuss about the properties of the distribution function. Since here we see that capital Fx equal to integration fx dx limit minus infinity to x. Therefore, if we differentiate this, it will give f dash x and this will be equal to fx. And since fx is greater than equal to 0, density function is always non-negative. That is fx greater than equal to 0. That means derivative of capital Fx is greater than equal to 0 means capital Fx is non-decreasing function. That is, the distribution function capital Fx is always non-decreasing function. Now, f capital F of minus infinity, this is equal to 0. We may prove this as here capital Fx equal to integration fx dx limit minus infinity to x. If we take here minus infinity, f minus infinity equal to integration limit minus infinity to minus infinity, same value fx dx. Here higher limit and lower limit be same, so this will be equal to 0. Number 3, f infinitive equal to 1. Here if in place of x we write infinitive, f infinitive equal to here integration limit minus infinity to infinity fx dx. We know that value of this is always 1. So f infinitive equal to 1. Number 3, probability for x greater than equal to a less than equal to b equal to here integration fx dx limit a to b. Here we may write this as integration fx dx limit minus infinity to b minus integration fx dx limit minus infinity to a, and value of this is capital FB and value of this is capital FA. Therefore, probability for random variable x greater than equal to a less than equal to b equal to capital FB minus capital FA. Now we solve a problem. Problem is the function defined as follow a density function? Fx equal to e to the power minus x for x greater than equal to 0 and fx equal to 0 for x less than equal to 0. This is number 1. Number 2, If so, determine the probability that the variate having this density will fall in the interval 1, 2. Number 3. Also find the cumulative probability F2. Now we solve one by one. Number 1. Here we have to show that whether this function is a density function or not. Here given that fx equal to e to the power minus x, x greater than equal to 0, and fx equal to 0 for x less than equal to 0. Since e to the power minus x equal to 1 by e to the power x, and this is greater than equal to 0 for x greater than equal to 0, implies that fx equal to e to the power minus x, e to the power minus x is greater than equal to 0 for x greater than equal to 0. And here fx equal to 0, also fx equal to 0 for x less than equal to 0. Therefore, fx greater than equal to 0 for all x. This is number 1. Now, integration minus infinitive to infinitive fx or dx, this equal to integration minus infinitive to 0 fx or dx plus integration 0 to infinity fx or dx. This equal to value of fx is 0 for x less than equal to 0. Here value of x is less than equal to 0. So this is minus infinitive to 0. Value of fx is 0 multiplied dx plus here integration 0 to infinity for x greater than equal to 0. Value of fx is e to the power minus x dx equal to 0 plus here integration of e to the power minus x is minus e to the power minus x 0 to infinity. This equal to minus e to the power minus infinity plus e to the power minus 0. This is 0 and this is 1. This equal to 1. Therefore, from 1 and 2, from 1 and 2, it is clear that fx is a density function. Number 2. Here we have to find the probability in the interval 1, 2. Probability for random variable x greater than equal to 1, less than equal to 2. This interval equal to integration 1 to 2 fx or dx. This equal to 1 to 2 in limit fx is e to the power minus x or dx. Since 1 and 2 are greater than equal to 0, and this will be equal to minus e to the power minus x 1 to 2. This equal to minus e to the power minus 2 plus e to the power minus 1. And this equal to minus e to the power minus 2 is 0.135 plus e to the power minus 1 is 0.368 and value of this is 0.23. Number 3. We have to find cumulative probability F2. Since F2 is minus infinity to 2 fx dx and this equal to integration minus infinity to 0 fx or dx plus integration 0 to 2 fx or dx. Here value of fx will be 0 as x less than equal to 0. So this equal to minus infinity to 0, 0 multiply dx plus here e to the power minus x dx integration 0 to 2 and this will be equal to 0 plus here minus e to the power minus x limit 0 to 2 equal to minus e to the power minus 2 plus e to the power 0. This equal to minus 0.135 plus 1 and this equal to 0.865. So our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.